So let's just go straight to the formula, which is pretty basic. We have y equals a, open bracket k, open bracket x minus t, close bracket to the power of n plus c. And keep in mind, n exists as all neutral numbers. What this means is n can only be positive integers. First, we're going to be talking about a. So brackets, right? So all constants outside the brackets have to do with vertical transformations and translations. All constants inside the brackets talk about horizontal translations and transformations. So let's start with A. A has to do with vertical compression and stretches and reflections in the x-axis, which we'll get to soon. So let's just start with an example. We have 2x squared here. So this would be our original x squared. What the 2 does, it multiplies all y values by a factor of 2. So this, you pretty much take the graph and pull it up, and you get a stretch. It looks like it's vertically stretched. Here we have 1 over 2. You can either say the y value is divided by 2 or multiplied by 1 over 2. Changed by a factor of 1 over 2, and it looks like you're pretty much compressing the graph vertically, so you're pushing it down, and that's what it looks like right there. And finally, we have our reflection of the x-axis. What happens here is you have a negative, your a value is pretty much negative, and what this does, it reflects in the x-axis. So what you had here would happen on this side. So you'd be reflecting it. So the end behaviors would be changing. Alright, so next up we're doing the constant k, and this is pretty much horizontal compressions or stretches. Keep in mind that when you're considering k, you're always doing 1 over k. So, for example, here we have 2x squared. So this 2 is pretty much 1 over 2. So what we're doing is we're multiplying the x by a factor of 1 over 2, rather than just 2. So what happens is we'd be taking the equation and pushing it in horizontally, compressing it, and it actually resemble a vertical stretch. Here we have 1 over 2. 1 over 1 over 2 is actually 2. So we're actually stretching horizontally by a factor of 2, which resembles a vertical compression of 1 over 2. And finally, we have a negative k value. What this does, it reflects the function, any function, by the y-axis. So like I said, it's an even function, and the special thing about even functions are they're symmetrical at the y-axis, right? So even if you flip it, they look the same. Next up, we have d and c. The constant d is pretty much left and right translations, and the constant c is up and down translations. Here's the interesting thing about d. When d is negative, we actually move it to the right, and when d is positive, we move it to the left. And obviously for c, when it's positive up, negative down. So you have x plus 1 squared minus 5. So this is our equation x squared. So if we had an x plus 1, our x plus 1 would actually, since it's d, we'd actually be moving it to the left by 1. So we'd have it here at 1. We'd be doing that. And our minus 5 is the c value, c constant, and we'd be moving it down by 5. So we'd be moving down by 5. So this would be our graph in the end. So here's the interesting thing. So each point is being moved by the value of 1 and 5, d and c. So our vertex is actually being moved around. So this equation is commonly also used for vertexes as well. So therefore it is called vertex form. Recap of what we just learned. So outside brackets vertical, inside horizontal. So our plus and minuses are translations, and our multiplying are our transformations. So key concepts. N must exist in all natural numbers, positive integers. Transformations before translations. That's really important. So you do transformations before your translations. So A, the constant A is a vertical compression or stretch, and when it's negative, it's a reflection in the x-axis. K is a horizontal compression or stretch, and when it is negative, it's a reflection in the y-axis. C moves the function up and down. When it's positive, it's up. When it's negative, it's down. D is interesting. It moves it left and right. When it's positive, it's left. When it's negative, it's right. And that pretty much summarizes 1.4 transformations.